Good morning and welcome back to Good Morning El Paso. We are joined by John Fausett, meteorologist with the National Weather Service, and I have got to point out the hot temperatures. I complain about it all the time. We have had near record temperatures. It has been so hot, but really what we're going to talk about today is temperature inversion because it's very common around this time of year. So John, just talk to us a little bit about temperature inversion.
Well, even with our hot temperatures, which I love, by the way.
No.
The nights are longer. With the dry air, the temperatures drop off. You'll notice the mornings have been quite a bit cooler, and when that happens, the cooler air is heavier. It tends to sink into the valley locations, and the warmer air is actually aloft. So as you go up higher, it gets warmer, at least for the lower part of the atmosphere. That's backwards. That's an inversion. Now, when you have a temperature inversion, the cool air doesn't want to rise, right? And the pollutants that start to collect and are trapped in that cool air, when you wake up in the morning, you can see a layer of pollution near the ground in the lower parts of the atmosphere. And that becomes even more and more common as we get deeper into the cool season. That is in the absence of maybe a cold front or an upper trough or some kind of storm system moving near, and that keeps the atmosphere flowing and doesn't allow that to happen. But, you know, the next morning or two, you may see that around sunrise, more common as we get later into the season. So, and I notice besides air pollution, which is the common result, you've got on there freezing rain. Fortunately, that is a rare occurrence here, but it is still possible. Ooh, you wouldn't want freezing rain because the air is warmer aloft in a temperature inversion, right?
Right.
Okay, so it's falling as rain. Then it drops into that cold air near the ground, could be below freezing, and it freezes on impact. We don't want that. We hardly get it.
Thank goodness. Would you say our topography plays a role in
Yes,
in
absolutely. In the western United States, you have these valleys. That's where the cool air likes to settle and collect, and you get those temperature inversions. That is from radiational cooling. You can get them from other, like a cold front bringing cold air in as well, but most common for us is just the overnight cooling.
Which I enjoy, by the way, the overnight cooling.
But the afternoon heating mixes out the inversion and clears us out, so there.
Okay. And something else that we want to briefly mention is our precipitation outlook. I know the winter outlook hasn't come out yet, but what are we looking at as far as rain this year?
Well, we have, Climate Prediction Center is still looking at a weak La Nina pattern, which is kind of opposite of El Nino, and that typically for us means below normal precipitation and often means above normal temperatures as well, but it's stronger on the below normal precipitation signal, unfortunately, and so when you're going with the odds, that's probably what you're looking at over the entire cool season. Doesn't mean you don't get a big storm here or there.
Yeah, it's still
it's
possible.
Just the average is dry.
All right, John, always a pleasure. Until, what, next month?
Yep.
All right, we'll be back after the break.